A person stands on a bathroom scale in a motionless elevator. When the elevator begins to move, the scale briefly reads only 75% of the person's regular normal force. Right? When the scale starts moving, the number on the scale changes briefly. We kind of talked about why in class. Calculate the acceleration of the whoa. Calculate the acceleration of the elevator is what I meant to write. And state its direction. All right, so force diagram on this thing. This is what's weird though. They never actually told you the mass of the person. But we can still draw a force diagram. And we're going to have to use a little bit of algebra here instead. So you know that the force caused by gravity is 10 times its mass. Well, just because we don't know what the mass is, there's no reason to freak out. We can still just write 10 times m. We can carry m algebraically throughout the problem, right? And then for the normal force, they told you that it's 75% of his regular normal force. Well, if the regular normal force is 10m, 75% of that would be 7.5m, right? Doesn't matter what value you put in for m. If normal is 75% of the force of gravity, it'll end up looking like that. Let me see if I can. I should probably shrink that to scale a little bit better because the downward force is bigger, right? By the way, before we even solve it, you can tell the net force is in the downward direction, right? If you got 10m going down and 7.5m going up, clearly the elevator is accelerating downward, which, by the way, is why you feel lighter than normal, because your normal force is smaller than the usual 10m. If the elevator were just sitting there, it would be 10m. But instead, you feel only 7.5m. So you feel less, and you've been on an elevator before. That means that the elevator is accelerating downward. It's either speeding up going down, or it's slowing down going up. Either way that you want to think about it. All right, so the net force equals ma, and you know that the net force in this case equals 2.5m. It's the difference between these two, right? After you subtract the forces out, equals ma. And an amazing thing happens here. They didn't tell you the person's mass here because it didn't matter. If we divide both sides by m, then we just get 2.5 equals a. And that's in the downward direction. So a equals, you could either write minus 2.5, or you can just simply state the direction at the end. Because remember, a negative is only a direction anyway. All right, so go play on some elevators. Don't hurt yourself. See you on the next one.